Reading a word problem to make a free body diagram. So the first question you're usually going to be asking yourselves is this object accelerating or is it at equilibrium? So some of the words in a problem that will give it away that something is at equilibrium. So that means zero net force in any direction, okay? If it says the object is at rest, all right? Because remember that is a constant velocity, your speed is just zero, okay? If it specifically says at a constant velocity, or it says something's moving with a constant speed and it's not changing direction, remember that's the same thing as a constant velocity. So that also means the net force is zero. Constant velocity means no acceleration. Another one you might see is an object floating. Okay, so in that case you can assume that at least vertically, up and down, all right, the force due to gravity is going to equal the buoyant force. Okay. Also, if, say, an airplane is flying, okay, because the lift is really a buoyant force as well. Now, if an object is accelerating, there's kind of two different cases. It will either usually say, or it's an object moving in a circle, all right, in which case it may have constant speed, but the direction is changing. We'll talk more about the forces that do that later on, all right, but just know that it is accelerating if it is changing direction too. But there will sometimes be problems where you have to actually just do the math, okay? Sometimes the problem won't tell you if it's accelerating or not, and the clues aren't there, all right? And so you'll have to do the free body diagram, all right, and add vectors together, all right? So we've talked about components, we've talked about the free body diagrams, we've practiced those. Tomorrow we're going to kind of put it all together and do some problems. So the other thing you have to do from a word problem is find which forces actually go in your free body diagram. So you'll have given forces, all right? It might say there's a pull at this angle of this many newtons, okay? Or you might say, all right, that there's a tension of this much in the rope. Or you might just be given in words some numbers in a direction. But there'll also be hidden forces that aren't mentioned, okay? Gravity isn't always specifically mentioned in a problem, but if it's in a gravitational field of a planet, all right, so if it's on Earth, all right, or it's not specified, it probably has a weight, all right? Normal force is also not always mentioned, all right, but if something's sitting on a surface, all right, a book is on a table, there's a normal force acting on it, okay? Let's see, the other thing, all right, so if friction and air resistance are not said to be negligible, you may have to include them on your free body diagram just to make sure you're not missing something. It may turn out later that they're zero, but they might be hidden in there and just not mentioned one way or the other.